Throughout the chapter, we are going to use rate of change concept. So let's recall what is it? It has to do with the slope of the tangent for a given graph. Now, how does this help? Well, the whole idea is it helps in understanding how one variable is dependent on the other variable. It helps in understanding how one variable depends on the other variable. Now, how to find the rate of change, that is the tangent at an instance? Very first thing is, you will see this in our few examples on a very basic level, that is, we'll need to figure out the function, right? Equation of the function, we need to figure it out. And the next thing that we'll need to do is, we need to differentiate it. Let me do a better job. Differentiate this and then substitute. Right? Say I want to look at what is happening with the graph at 1, I need to substitute it. So let me summarize it in this manner. First, we need to understand what's happening. Then on that, we need to look into the variables. And on that, we need to build our expression or equation. Once we have that, all we have to do is differentiate it. Differentiate with respect to the independent variable. And finally, we need to substitute. Either x as some value or t as some value, it depends what the variable is. So this is the funda. So there are a few more things that we need to understand about rate of change. That is, it can have positive value, it can have negative value, or a value of 0. For a given interval, right, if the graph happens to be positive, what does it mean? Mathematically, it will mean that the derivative of that value will have values which is greater than 0. The derivative, that is. Okay, again, I'm talking about few instances, so maybe something like this. Now, graphically, how does it look? Graphically, say this is A and B, right? So it might look like this. It might look increasing, but yeah, slowly reducing as well. It is increasing exponentially. So basically, the graph will always, within that interval, again, not like it can keep doing this throughout. It can, but yeah, graphs can vary. So it is always increasing in the interval in A and B. Including or excluding, that depends. Anyways, here I will written it to be including, so let me continue it to be so. So similarly, we can have negative. So basically, this would be a value which is less than 0. So graphically, how does it look like? Between that interval, again, here we're looking at an interval. So between that interval, it would maybe look like this or look like this. Again, these are just two possibilities out of infinite possibilities. So within that interval, it is always reducing. Right, between A and B. Now, in case of 0, there are many more than, well, I'll put it in this way. There are quite a few possibilities. So mathematically it's equal to 0. That is one possibility. Graphically, we can just have a point wherein the graph is either increasing or decreasing. What I mean is, 0 slope indicates a breakpoint. That is, the graph might be moving from negative slope to positive slope, or from positive slope to negative slope. So all in all, I can tell that at the point of, say, I'm taking it as a, at x is equal to a, not 0, a. So this is known as inflection point. I just call it as break point, but yeah, technically in your mathematical books you'll find it to be inflection point. This is one of the possibilities. Of course, we have one more possibility, that the f of x is nowhere dependent on x. That is, the variables are independent of each other. That's also a possibility, but that I'm not looking into. So basically this indicates the slope of the graph either can be shifting from positive to negative or negative to positive. So these are two possibilities, A and B. Okay, so let me show one particular graph for you guys. So this is the equation of the graph, and this is the graph itself. So there's one more graph below the original graph, that is a derivative of this graph actually. So the above graph's derivative is plotted over here. What does it mean? See, you can see I can vary that this point's x coordinate and the y coordinate is calculated, and the tangent at that point is calculated. This tangent's value is being plotted over here. Again, I repeat, this is your graph for this function, and I'm taking random points along this graph, and at those points I'm drawing the tangent, and the tangent value is being plotted along your this graph, second graph. So this graph is your derivative versus x graph. So this is basically f of x, f prime of x versus x, right? I hope you guys got the gist. So this is f of x and this is f prime of x with respect to x. Now, first thing is, we can see that there are two different colors. This bluish color or purple color in between that, this indicates increasing slope, and this orange color indicates decreasing slope. Okay, now, so let's have a look at this. So why is it increasing or positive slope? So it's positive slope because as and when we are moving right, it is increasing, right? The line is increasing. It's a very fundamental thing. You guys should know when the graph is increasing and decreasing. That is just at least the line at least. So when we are moving right, if the graph is increasing, if it's moving up, then it is positive slope. So from this point, wherever I am, as and when I'm moving, it's increasing, but the rate at which it's increasing, it's reducing. And exactly at this point, that is your break point, actually called as inflection point. That's when the graph becomes 0. So you can see the slope value over here. It's almost 0. So this is the break point. As you can see, the derivative graph also is moving from positive y coordinate to the negative y coordinate. So if I move a bit more to the right, so it's crossing the x-axis. So this is your x-axis, right? Can you see that? In the derivative graph, look at the line 0. Where is the y 0? It's over here. And so it is moving down the x-axis. Means the y value is negative. And you can see the slope, it is reducing. As in when we move from left to right, the line is going down and the slope value is negative. So it continues to be negative, 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 negative. And at this point it is again 0. Right? Again, that is your inflection point. And post that it is positive, positive, positive. So what I'm trying to show is, in a graph, we can have anything happening. So what helps us is the inflection point. That helps us to understand it, and you'll see how it is used. It's going to be used in quite a few chapters actually, this idea. It looks simple, but yeah, it's going to be used a lot. Okay, yes. So there's a lot to understand. So this is just a small introduction. So copy everything. In time, you'll get introduced to all of this as a separate topic. There's a lot of numericals that we'll be doing. So yeah, you'll have a better introduction in time.